Now on to the next one. That's what we do, right? Now find the sum of the first n natural number. What are natural number? That natural number are also the same as counting numbers. Natural number are also the same as what? Counting number, and it begins from 1, it ends in infinity. But we are not doing it to infinity here, my brother, my sister. We are told to find it to the first n. So this is the question. Find the sum of the first n natural number from 1 down, sum. That makes it series. For you to get the sum, what do you do? What do we do? Just as though we are proving it, we can do it like this. Or somebody is saying, must I do it like this? This method is kind of funny. I don't understand. What do? We wrote the series in a reverse form. This is an ascending order of the series. Then we wrote it in descending order, from the highest to the lowest. You know, this one here, there is a common difference, 1. So when you add 1 to this, if you are going it in ascending order, you'll be adding 1. In descending order, you'll be subtracting 1. So what do? The highest, then you subtract 1 again from this, you get minus 2. Subtract 1 again, you get minus 3. Subtract 1 again, you get n minus 4. Subtract 1 again, you get n minus 5, down to the least term, that is 1. Now, adding this one here and this one, that's how we get this here. That will be n plus 1. At this point now, you have this one, n minus 1, this one too. This will be, you're adding this to this. Like what I'm saying, adding, please, we are adding. So this one will be n plus 1, that's the first thing. This one, n minus 1 plus 2, that will still be n plus 1. N minus 2 plus 3, that will still be n plus 1. At every point, we're having n plus 1, n plus 1, n plus 1. So how many n plus 1 we now have? The number of n plus 1 we have is dependent on the number of 10. So that is the number of s. If I have 2 terms, it will be 2 into bracket n plus 1. If I have 3 terms, it will be 3 into bracket n plus 1. If I have 4 terms, it will be 4 into bracket n plus 1. I get what I'm saying. Don't forget we sum 2 series here. That's how we have in 2 here. The 2 here is to show us that we sum 2 series. Now, the next thing we now do is what? We now say, okay, very good, very good. You don't need to worry yourself. Then how many n plus 1 we now have? Since they say we should find the first n. So we have n plus 1. And we have n plus 1. That's why we get n times n plus 1 to show you that we sum of n. Because we have n plus 1, another n plus 1, another n plus 1. It depended on what the number of terms I have, which is n term. That's why I got n plus 1. But there's a 2 years, and we want to find Sn, not 2Sn. So divide both sides by 2. So the answer is n, open brackets, n plus 1, all divided by 2. I will get what I'm saying here. All divided by 2, all divided by 2. So that gives us the answer to that. Or somebody is thinking, I don't know this at all. I've not done this before. Is there another method? There is. And what do you do to get that? There is another method. Let me show you real quick how to do that using the general method. Some of you know. So using the general method, I have 1 plus 2 plus 3 plus down plus n. So the first term here is 1. This forms an AP, of course. How do I know? Because there's a common difference. The common difference there, you get T2 minus T1, and the common difference is 2 minus 1, 1. And you want to get the sum of n, and then it's n here. Sum of n. I want to get the sum of n term. Sum of n term. And here my n is n. So since I have the first term, I have the common difference, I have the n term. You know, sum of them is given by n over 2 into bracket 2a plus n minus 1 times d. Or we use n over 2 into bracket a plus l. So if you have the common difference, use this. If you have the last term, use this. So we have the common difference, we are using this other one. So that will be Sn equals, what's our n? Our n is en, that's n over 2 into bracket 2 times our first term is 1 plus n minus 1. Our common difference is still 1. So that will be n over 2 into bracket 2 times 1 is 2 plus n minus 1 times 1 is still what? N minus 1. Close the bracket. That will be n over 2 into bracket 2 plus 1. So that will be plus 2 minus 1, plus 2 minus 1, plus 2 minus 1, plus 2 minus 1 is what? 1. So I get n plus 1. So both ways, we get the same thing. That will be n into brackets n plus 1 all over 2. And that's the sum of 10 we have. Both ways, we get the same thing. Now the next question, is that they said, show that this equals this. I will solve it myself. I want to take you through this procedure step by step in case you have that kind of question. Let me show you. We want to show that the summation from r equals to 1 to n of, I guess, 5r plus 4. Let me go back a little bit. That is equals n over 2 into 5n plus 3. This equals n over 2 into 5n plus 3. Let's go back. Just want to confirm. I don't like kind of going far and then you discover there's a mistake around some point. It's always painful. Plus 13. You see now? It's good I actually reverse my order before beginning to solve. So it's plus 13, plus 13. Very good. How do we do this? Now let me show you. Now we want to work from the RHS. Let's leave this is the LHS. This is what I want to show. Sorry, this is what I want to show. This is the mark. So let me leave that mark somewhere. Now let me deal with summation from r equals to 1 to n of 5r plus 4. Now there's a rule of summation, just like integration, just like every other mathematics, just like when a constant want to multiply a two expression, we say that thing we multiply them pairwise. So this one too can multiply them termwise. That's what I mean, a termwise. So this one will go for this term, this one will go for this term too. So this is the same as summation r equals to 1 to n of 5r plus summation r equals to 1 to n of 4. Now, one of the rule again is that this is the same as me writing, bring this thing out, bring the constant, this is a coefficient of our r, bring that coefficient r, that is the same as 5 summation r equals to 1 to n of r. Do we see that? That's what I got there. Plus 4, that's the same as 4 times 1, so I will write is 4 summation r equals to 1 to n of what? Of 1. Now this one here, let me interpret this for you so that you understand. What does this mean? This means the summation of numbers from 1 to n. That was what we did before. Oh, somebody said we remember. That is it. The summation, this is summation addition. This one, the interpretation of this summation r equals to 1. Let me erase this thing a little bit. I don't like it rough. Summation r equals 1 to n of r is the same as r is numbers. The sum from 1 to n, that will be 1 plus 2 plus 3 plus down plus n. And that was what we did. We got that to be what? N into n plus 1 all over 2. That is, we already know this. Someone will now say, how do we go about summation r equals to 1 to n of 1? It means you are telling me that we have repetition of 1s from 1 to n. Repeating 1 from 1 to n, that will be 1 plus 1 plus 1 plus 1 ... plus 1 in n times. And that is the same. If I stop in 2, if this is r equals to 1 to 2, that will be 1 plus 1, 2. If I stop in 3 term, that will be 3. If I stop in 4, that will be 4. Because 4 times 1, 4 times n. You understand? Now, if I stop in n time, that will be 1 times n, which is the same as n. So this thing too, we've gotten it to be n. N here, this one is n, and this one is what it is. So let's substitute. Let's see what you get. Substitute. So that will be 5 into bracket. Hey, just at the start of it, bro. So that will be 5 into brackets n open bracket n my n plus 1 all over 2, then plus 4 times 4 times n. I'm sorry. Somebody saying, how do we get it? This is n here, so that will be 4 times n. 4 times n for n. Now this one here, open the bracket, that's what? N times this. So we can still, I think the question, want to leave it in terms of n, if I can remember so well. But let's open the bracket, I guess. Now, should we? Let me see where we are going. in mathematics, n is left. We leave an n out here, so let me leave my n out too. So let's not just solve as though we don't have a direction. So I'll bring this n out. 5 times n, 5 times n times this is the same as n times 5 times the whole of what I have here, all over 2 plus 4n. But still, this is the same as n. Now make it a common denominator. That will be LCM. Sorry, don't mind me. Let me clean this first. Make it a common denominator 2. Because there it was a common denominator. So 2 into 1. 1 times the whole of this. That will be n into 5 into n plus 1. Then this is same as over 1. 1 into 2. 2 times this. 8n. So we continue. This is the same as n into 5 times n, 5n, 5 times 1, 5, plus 8n, all over what? Don't mind me. This bracket shouldn't be here. How do I mean? This is different from this. This is separate term. This is separate term. So this one is just 8n all over 2. So we get what I'm saying? Now, again, what do we have? Now, we can open the bracket. In fact, it is expedient we open the bracket here. It's expedient. So let me open the bracket. I want to open this bracket. So this will be, that will be 5n square plus 5n plus 8n all over 2. So what is common there? Hey, something is common. Yay. What is that thing? Relax. Before that, safe. Let's enjoy. That should be 5n square. 5n plus 8n. 13n all over 2. N is common to this. That will be n into brackets 5n plus 13 all over 2. Do we get what we want to get? We get it. Let's check. N over 2 into 5n plus 13. N over 2 into 5n plus 13. This is actually the same. You can just write it as n over 2 into 5n plus 13. So that is that. That is the end of the question. We've been able to solve it. Still on this 3, the question is, for what value of x? For what value of values of x is the function 4x squared plus 9x plus 2 strictly positive? Let's go real quick. Now, hey, I forgot my question again. I'm sorry, please. Pardon this boy. Now, that is 4x squared plus 9x plus 2. 4x squared plus 9x plus 2. 4x squared plus 9x plus 2. 4x squared. Don't mind me. 4x squared plus 9x plus 2. For what value is it strictly positive? If something is strictly positive, all numbers that are greater than 0 are strictly positive. That is, for what value is it greater than or equal to 0? Strictly positive. In fact, it is strictly positive, so it will be greater than 0, not or equal to. Strictly positive, not or equal to. If we say positive, that is, it is 0 greater than 0. Strictly positive greater than 0. So what do we need to do? Let's solve this thing as though it is a quadratic equation. Let's see. Let's solve it as though it is a quadratic equation. Solving this one equal to 0. Factorizing this will be 4x squared. 4x squared times this, that's what? 8x squared. Two numbers you multiply to get 8x squared. You add to get 9x. That is 8x itself plus x. That will be plus 8x plus x plus 2. So that's a bracket. That is a bracket and another bracket. In this bracket, what is common? 4x, then you have what? X plus 2. And in this bracket, what is common? Nothing. No. 1 is common. Don't say nothing. X plus 2. Then what do you have? These two, the same thing. Pick one. X plus 2. And then these two join it. 4x plus 1. Now, We cannot solve this question for greater than 0 just like that, just having it like this. Let's set it equal to 0. Had it been I set these things equal to 0, then my x will be minus 2 or 4x will be minus 1. So x will be minus 2 or minus 1 over 4. Had it been I want to produce this thing on the number line, come enjoy number line. Now, I have minus 2, minus 1 over 4. Which one is greater? Minus 1 over 4. You know, once a number is having a negative sign, the biggest will be the smallest, and the smallest will be the biggest. That is what I'm trying to say, is that naturally on a number level, 2 is greater than 1 over 4. But with a minus sign, then minus 1 over 4 is greater than minus 2. So the one that will come first will now be, if I'm, you know, this is negative x axis, and this is positive x. So this is minus 2 will come first, then I have minus 1 over 4. Now I have how many regions? 3 regions. Region 1. Let me differentiate that. Oh, let me use another ink. Oh, I have region 1. Now I have another region. Region 2. I have another region. Region 3. We want to know which region will satisfy that solution. How do we get it? Now let's go. Now these are our 2 factors to this question. Now let's write that. The 2 factors. I have x plus 2. Let me use a better ink, black. And the second one, 4x plus 1. We have how many regions? 3 regions. Let's make it region 1, region 2, region 3. Now what do we do? In this region, this is the region of numbers that are less than 2. This is the region that are of number between minus 2 and minus 1 over 4. And this is the region of numbers that are greater than, are you get what I'm saying? Based on the number line. Are you understanding? You understand what I'm saying? So what do you do? What do you do? You pick a number. Are we here? Pick a number that is oh, I should have a 3 region. Okay, yeah, that is the 3 region. The first region is the region of numbers that are greater than this region. We want to check something. That is the first region. Check the region for number greater than that. So that will say no, number less than. If you go left, that's less than. So check for x less than minus 2. Now there's a region for this. We see that's region. This space may not be able to house it. Let me write it. That's a region that is greater than minus 2 but less than minus 4. We don't want it to get to those ends. You understand? So we now say that will be minus 2 is less than s, and s is less than minus 1 over 4. That is this region here. And the last region is s greater than minus 1 over 4. Now pick a number sufficiently here. Make it a no number. Don't stress yourself. Pick a number here. Let's say I pick minus 3. You can pick any number that is less than minus 3. You know, when you go down minus 4, minus 5, minus 5, you can pick any number so far the number is less than minus 3. It can equally be fractional. It can be decimal, but don't go by that. Don't give yourself unnecessary headache. What you need there is just the sign, not the number itself. So let me pick a positive number. Let me pick a number within that region. Let's say I pick a negative whole number. A negative whole number. So let's say I pick a minus 3. Now minus 3 plus 2. Somebody is saying that's minus 1. What you need there is the sign. So minus 3 plus 2 is minus 1. The sign there is what? Minus. Again, minus 3 plus 2. Minus 3. I pick a minus 3 in this region. I pick a minus 3 in this region, in this region. So minus 3 plus 2, that is what? A minus 1. The sign is all you need. Drop the minus. Now, go to the next one. Minus 3 times 4, because it's 4 times 8. So 4 times minus 3, that's minus 12. Minus 12 plus 1, that's minus 11. Again, minus. Leave that. Go to the next region. A number that is sufficiently greater than minus 2, but less than minus 1 over 4. Let's say minus 1. Minus 1 is greater than minus 2, is less than minus 1 over 4. Minus 1, that's, we are in this region now. I'm in this region. So the next one, what do you say? What do you have? Minus 1. I picked minus 1. So minus 1 plus 2. Minus 1 plus 2 is 1. 1 was the sign there? Positive. Oh. 4 times minus 1. Minus 4. Plus 1. Minus 3. That's negative. Whoa. The next one, let's go to this region. Numbers that are greater than numbers that are greater than numbers that are greater than -1/4. Let's say pick 1 here to 1, you can pick 0. Well, 1 plus 2, 3. Oh, that's positive. 4 times 1, 4 plus 1, 5. Oh, that's positive. Now let's take the product, because right from this place we have the product of these two to be the still equal to this. The product of these two is still equal to this. So let's take the product of the two. Now this times this, minus times minus, plus, plus times minus, minus, plus times plus, plus. So now what's our question? They said find the region to which this thing is greater than 0, and I've said this thing is greater, this expression is greater than 0 at the point where we have positive numbers. All positive numbers are greater than 0. Then everyone that yield a positive sign will be the region that satisfies. I get what I'm saying? So the solution of this and everything within this region, and everything within this region. I get what I'm saying? That's what satisfies. So how do I write it? In limit, or I will write it in bounded form. So I will say that will be negative infinity. Hey, sorry. That's negative infinity. What's wrong? Please pardon me. Negative infinity, comma what? -2 union -1/4 to positive infinity. So this is the region. This is the solution where the thing is strictly positive. I didn't mean they said negative. You only pick this, and you write that to be what? Just what we have there. -2 less than or equal to 4. You write -2, comma -1/4. Do you understand? So that's the solution to that question.